Bismillah ar-Rahman ar-Rahim. Shall we start this section? Basic integration rules, section 8.1. The first section in this chapter, chapter 8, is about the integration techniques. This section, there is nothing new. Just it's kind of review or you're talking about all the things we did about integration techniques. So one of the main integration techniques is you fit the integrand to the basic integration rules. For example, yeah, this is how we know e to the integral of e to the power x is e to the power x plus c. A, you have to divide by ln a, sine minus cosine, cosine is sine, tan, secant square is tan, cosecant square is minus cotan, secant tan is secant, cosecant cotan is minus cosecant. And we have these three, which we did, I think, in 5.7 or 5.8. With just like the sine inverse and tan inverse and secant inverse. Yeah, so you need to ensure that you know these formulas, and these are the procedures for fitting the integrands. Sometimes you need to expand. You need to expand something to the power square. You need to expand this so that you can deal with it. You separate numerators. Sometimes you make it like something plus something. Okay. You complete the square to make it ready in this format, in this one of these three formats. Sometimes you divide, especially if the degree of the numerator is equal or less than or greater than the degree of the denominator. Sometimes you add and subtract terms to make it so that you can have cancellation. Trig identities. Sometimes you use the trigonometric identities. Yeah, to do the integration. Like if I want to do the integration of cotan square, you cannot. There is no quick formula. But I make it cosecant square minus 1. Yes, I have formulas for that. Sometimes you need multiply by a function, 1 minus sine, or to make it cosine square, so that you can simplify it. So these are just some of the hints or some of the techniques you may use to solve or to do the integration. I think we did most of these things in the previous chapters. So now let me do examples. Find this integral. The idea in this question is what? It's similar. This seems to be similar integration, but no, they are not. In each one, you need to deal with it in a different way. So the first one, I need this formula. That's it. So my A, will be 4 over x squared, or let me write it the same way as it is here. 3 squared plus x squared. 3 squared. 9, which is 3 squared. This 4, I can take it out. Who cares about this? 4, just a number. 1 or dx over 3 squared plus x squared. Just apply the formula. I have 4. This is 4. What is A? A is 3. So I have 1 over A, 1 over 3. Arctan x over 3 plus c. And that give me what? 4 over 3 arctan x over 3 plus c, which is this one. B is the same thing, but I have 4x now. I cannot do it this way. So what I will do substitution. You notice if I let u equal x squared plus 9, then my du will be 2x dx. So this integral 4x over x squared plus 9 dx, I can rewrite it. I need 2. So I take 2 out, and I leave 2x over x squared plus 9 dx. If that is the case, I'm getting what? 2x dx is du over u. And going to give me 2 ln absolute value x squared plus 9 plus c is always positive. So I can write 2 ln without the absolute value. But x squared plus 9 is always positive. So this is the answer. The third case, where I have the same degree. These two are the same. The degree is 2, and the denominator degree of 2. So I need to do the long division. This is my first step. I can't do it in another trick, but let me do the long division. Yeah. That give me 4x squared plus 36. Minus, that will be minus 36. So 4x squared over x squared plus 9 dx. This quantity or this expression, I can rewrite it as 4 minus 36 using the long division. I just rewrite the result of the long division. Yeah, let me write the minus here. Better. Dx. Now we'll do the integration, which is what? 4 is only 4x. This one is similar to this one, but now it's minus 36. So it's minus 36 over a arctan x over 3 plus c. So the answer is 4x minus 12 arctan x over 3 plus c, which is this. As I said, there is nothing new in this section, except it's just kind of review, or just to give you a hint about how to do it. Now, assume I have 4x cubed, not 4x squared. So I have 4x squared. I say 4x cubed. For sure, I need to do the long division. That give me 4x. Multiply. You have 4x cubed plus 36x plus minus 36x. So this integral will be what? 4x minus 36x over x squared plus 9 dx. What's the integral of 4x? Is 2x squared. This one, I need the integral of this. Take the 36 out. X over x squared plus 9 dx. I will use the let. So I can say let u x squared plus 9 du will be what? 2x dx. So I need 2 and over 2. So that'll give me 2x squared minus 18. Now I have du over u, which is ln x squared plus 9 plus 3, which is this one. As I said, these are easy ones, but you need now to deal with it. Okay, this one, what I will do. Sometimes you need to split, as we said here. Sometimes I need to separate the numerator. And this is what I will do. So if I separate the numerator, I have what? 0 to 1, x over this, plus 0 to 1, 3 over this. And I notice one thing. This one, let substitution, can do it. This one, if you go back, is similar to this one. So I need arc sign, u over a. Okay. So let me do it. In the first one, I need let for the first one. Let u equal 4 minus x squared. Du will be minus 2x dx. I need x, so minus 2, minus half outside. That gives me minus half, integral from where to where? 0, that is 4 to 3, 4 to 3. Okay. Yeah, 4 to 3, no, who cares? I have du over, I have du over square root of u. So let me call this I, and this is I1, and this is I2. So let me do I1 completely, and then I will do I2. Yeah, what is this? This is minus half, minus half. This is u to the power minus half. You add 1, that will be half. This is u to the power minus half du. So I add 1, it will be half multiplied by 2, u to the power half, from 4 to 3. From 4 to 3. And that give me what? That give me minus square root of 3 minus 2. Okay. So it is 2 minus square root of 3. Now I'll go to the second one, I2, which is the integral from 0 to 1, 3. Let me take the 3 out. I have 1 square root 4 minus x squared, which is similar to what? Which is similar to this one. So my A is 2. So I have arc sine x over A, x over 2. So my A is 2. This is 2 squared, dx. So I have 2 arc sine or sine inverse. Sine inverse x over 2. From where to where? From 0 to 1. Okay. That give me what? 3 sine inverse half. What is sine inverse half? Yeah. Sine inverse half is what? Pi over 6. When sine is equal to half, which angle? Pi over 6. Minus sine inverse 0, which is 0. So that give me pi over 2. So the integral will be I1 plus I2, and that will be 2 minus the square root of 3 plus pi over 2. And that is the answer. Okay, x plus 3, I think is the same one. Yeah, we did it. خلاص. No need to do it again. X squared over this. Need to think of it. Yeah. What I will do in this case, yeah, it seems I'm going towards the same thing like this one. But I need to be careful now what choose what. So if I let u equal x cubed, because I need here a square minus u square. So x to the power 6, so I'm making it this way. X square square root 4 square minus x cubed all square dx. So if I let u equal x cubed, du will be 3x squared dx, which is what I want. This is now in the numerator, I have du here. So that will make it. So I'm getting what? 1 over 3 integral of what? Du over square root of 4 square minus u square. If I let u equal x cubed, which is clearly now similar to this one. So I'm getting what? 1 over 3 sine inverse u over 4 plus c. Don't forget what is your u. It's x cubed over 4. That would be the answer. 1 over 1 plus e to the power x dx. Yeah. One trick, like what we did, like what we said here, sometimes I am multiplying by something. So I can do this trick here. I have integral 1 over 1 plus e to the power x dx. I multiply by e's minus x and over e's minus x. I can do this. So what I'm getting e's minus x over e's minus x plus 1 dx. Now I will let u is 1 plus e's minus x. du will be what? Minus e's minus x. So I need minus. So that'll give me minus du over u. And that give me minus ln of u plus c. And that is what? Minus ln 1 plus e's minus x, which is always positive, plus c. So also this one, I can simplify as what? 1 plus 1 over e's minus x. That give me minus ln e's minus x plus 1 over e's minus x. That give me minus ln e's minus, oh, sorry, this is e to the power x. So I have e to the power x. Oops. Yeah, it's 1 over e to the power x. I have e to the power x plus 1. That will be e to the power x plus 1 over e to the power x. So it will be ln e to the power x plus 1 minus ln e to the power x. And that give me, this is x. So that give me x. That give me x minus ln ax plus 1. Don't forget plus c. Always there's plus c, plus c, plus c. That will be the answer. Cotan x ln of sine x dx. What is this? If you notice, if you remember, you go back to the formulas. Look at this. Integral of cotan is ln sine. So this is my du. So if I let u equal ln sine x, what will be du? Du will be over sine cosine dx, which is cotan x dx. So this is my du. So this integral is u du. And that will be u squared over 2 plus c. What is u? It's ln of sine x all squared over 2 plus c. And that will be the answer. Tan squared to x. There is no formula for tan square. Do you have a formula for tan square? No. But there is a formula for secant square. Okay. And I know that 1 plus tan square with any angle, x to x, will be secant square to x. So I can write tan square as what? As secant square to x minus 1 dx. I know how to integrate this. Either I'll do it by substitution or I can do it quickly. I say this is half tan to x minus x plus c. You can check this. You differentiate you will get what? Half secant squared 2x times 2, which is secant squared. So that will be the answer. Now these are questions from the old exam. Actually, what I did, there is nothing special about this section 8.1. So I tried to collect the questions which can be solved without using the techniques which we will discuss later. This one, you set with substitution to calculate this integral. What I will let you equal cosine x. du will be minus sine x dx. Oops. So I will put the minus sign here and the minus sign outside. So that will be minus from where to where? Cosine 0 is 1. Cosine pi over 3, which is 60, it will be half of what? 1 minus u over u square. This with the minus sign, with the dx, that will be du. Done. So I have what? Can multiply by the y, by the minus 1 inside. That give me u over u square minus 1 over u square du. As we said before, sometimes we can separate the numerator. Or you can do it quickly, actually. That give me what? Don't forget the minus sign. Or instead of forgetting the minus sign, make this from half to 1. Interchange is multiply by minus, that will kill it. So I have what? Integral from half to 1, u over 1 over u. That will be ln of u plus 1 over u from half to 1. That give me what? Ln 1, 0 plus 1, that is 1 minus ln half one over half, that will be plus 2. So that give me what? 1 minus ln half is what? Is minus ln 2. This is to go as a power, yeah. Minus 2. And that give me ln 2 or 1 minus ln 2. Minus 1 plus ln 2. Yeah. Now these are all the exams. Like now I have the degree is more, so I will do long division. Because I need to do it completely. That will be W. So I have W square plus 3W plus minus plus, well, minus, I will not stop. Because the degree is still, this is minus 3W plus 3. The degree 1 and the degree 1. I'll continue. That W minus 1 until minus 3. Sorry. They have minus 3W minus 9. Minus 9. So plus, that give me 12. So this integral, or this expression, I can rewrite it using the long division as W minus 3 plus 12 over W plus 3 dx. I just rewrite this using the long division. Now I do the integration, which is easy one. W square over 2 minus 3W. I don't know what is this. W square over 2. And this is 12 ln absolute value W plus 3 plus 3. And that is the answer. Okay. Sometimes I need to do completing the square. So I have x squared plus x plus 1. We add half the coefficient of x squared. So I have x squared plus x to make a complete square. That will be plus 1 over 4. This is coefficient is 1. Half of it is half. Square it. Plus it will be 1 over 4. This is 1. I subtract 1 over 4. So I'm adding nothing. So that gives me x squared plus x plus 1 over 4 plus 3 over 4. And which is x plus half. all square plus 3 over 4. Will that help? Yes, because it will be from minus 1 over 2 to 1, minus half to 1. 1, I just rewrite this in terms of this one. X plus half square plus 3 over 4 dx. Yeah. I can say if we have let u equal x plus half, du equal dx, just I need to change the limit of the integration. I have what? 29 and I equal this. Okay. Now with the minus half, it will be minus half plus half, that will be 0. With 1, it will be 3 over 2. Okay. And I have du over u square plus 3 over 4. Or I can rewrite it from 0 to 3 over 2 du over u square plus square root 3 over 2 all square. What is this? This is similar to this one with a square root of 3 over 2. So it's ready now. So I make it going with the same format. So that give me, we say this is a, yes. So it will be 1 over a, 2 over square root of 3, tan inverse u over square root of 3 over 2, which means u over square root of 3, and that from 0 to 3 over 2. Now, what will happen? So I have 2 over square root of 3 times tan inverse of what? 3 over 2, 3 over square root of 3. Minus tan inverse of 0, which is 0. So I need this. What is tan inverse? 3 over square root of 3. 3 over square root of 3, which can be written, if you rationalize it, it will be tan inverse, to see it clearly. Multiply by square root of 3 over square root of 3. You are getting what? Square root of 3? Yeah. 3 over square root of 3. Multiply by square root of 3 or square root of 3. That will be 3 square root of 3 over 3. That will be square root of 3. So tan inverse of square root of 3. Which is what? Pi over, I need the sign to be square root 3 over 2. And that is pi over 3. That gives me 2 over square root of 3 times pi over 3. So it is 2 pi over 3 square root of 3. Which is this? It's a matter of calculation. 1 minus tan theta over 1 plus tan theta. Yeah, what I will do, I can't change everything into sine, cosine. And let us see what will happen. As I said, there is nothing new in the section, just a kind of a review of what we did before. So tricky things there and there. So I change everything into sine and cosine. That's the idea in this question. D theta. That gives me what? Integral of cosine theta minus sine theta over cosine cancelled to numerator and denominator over cosine theta. Make it sine theta plus cosine theta, d theta. The main idea, if you notice it, if I let u equal sine plus cosine, I know what is this. Sine plus cosine, then du will be what? Cosine minus sine d theta. So actually I have here du over u, which is ln of u plus c. So I have ln, what is u? Sine plus cosine plus c. What is this? I say it's just sometimes just a matter of calculation. This seems to be a complicated question. It's very easy question. You notice one thing, e to the power a ln x. This is what? E. This will go as a power. E to the power ln x to the power a, and that is x to the power a. This is number one. I did nothing, just I rewrite this one. What about this? E to the power x ln a. That will be e ln a to the power x, and that will be a to the power x. So I is the integral of x to the power a plus a to the power x dx. And we know their formulas. X to the power a, what is the formula? It will be x to the power a plus 1 over a plus 1. What is the integral of a to the power x? If we forget the formulas, where is it? A to the power x. This is a to the power x. So it will be 1 over ln a to the power x. That gives me a to the power x over ln a plus c, which is next one. Sometimes we expand, as they said here. Sometimes we expand. We open the square. Okay, let us see what will happen. And there is another trick. Yeah. So that will be what? Integral from 0 to pi over 2. I expand that. 4 minus 4 sine theta plus sine square theta d theta. So I have three integrals. This is I can do. This is I can do. What about this one? I can do. Using what? I need to use this trick, which is cosine 2 theta equal 1 minus 2 sine square theta. In other words, sine square theta is what? Is, take this to the other side, and this is half minus half cosine 2 theta. So this integral will be from 0 to pi over 2, 4 minus 4 sine theta, which is easy to do. And this one, I rewrite it as half minus half cosine 2 theta. So that implies sine square theta. Take cosine inside to divide by half. Half minus half cosine 2 theta. Now I can do the integration. That give me what? 4 theta. This is plus 4 cosine theta. I know the integral of sine is minus cosine times the minus. Plus half theta. Actually, I can combine them at the beginning. It's okay. Plus half theta. From where to where? Still, minus, this is 2 theta. I can change it into u, or I can do it quickly. I divide by 2. Minus 1 over 4 sine 2 theta. Yeah, cosine, integral of sine, cosine is sine. And that from 0 to pi over 2. Okay. Now let us do the calculation. I have this 4 plus half, that will be 9 over 2 times pi over 2. So I have 9 over 2 times pi over 2 plus cosine pi over 2, that is 0. Gone. I get rid of this. Sine 2 times pi over 2 to sine pi, which is 0. Gone. So this is minus. What the 0? This is 0. Cosine 0 is 1. This is 4. 0. Sine 0 is 0. That's it. So I have 9 pi over 4 minus 4, which is this. 1 minus cosine x. Square root 1 minus cosine x. What shall I do? Interesting. Yeah, you need to do these tricks. Yes, I will do the same trick like what we did here. Cosine 2 theta is 1 minus 2 sine square theta. Okay. I need this 2 cosine. Yeah, I need the other one. And it's also 2 cosine square minus 1. That is cosine 2 theta. So cosine theta will be 2 cosine square theta over 2 minus 1. This is the angle. Okay. So I will change cosine theta or cosine x in this case into this one. So 1 will be cancelled. So minus cosine theta. No, I think I need the sign. Sorry. I need the sign, not this one. I need this one. So from here, cosine theta will be what? Will be 1 minus 2 sine square theta over 2. So minus 1 minus cosine theta will be 1 minus 1 plus 2 sine square theta over 2. This is going to be every time. Okay. So that gives me 2 sine square theta over 2. Now I plug it into the square root. I'm doing nothing. Huh? I'm just rewriting the function. I'm rewriting this function. No need to change the limit of integration. That is I will be minus pi over 2 to 0 of square root 2 sine square theta over 2. D theta, or x over 2. That is what? That is square root of 2 minus pi over 2 to 0, absolute value, sine x over 2, dx. Okay. If x is between minus pi over 2 and 0, I need to check this angle, x over 2. X over 2 will be between what and what? It will be between minus pi over 4 and 0. So it's in this quadrant in the fourth quadrant. So I need a minus sign. So we need a minus sign. So that minus the square root of 2 minus pi over 2 to 0 of sine x over 2 dx. So the absolute value give me minus sine x over 2. And I took the minus outside. Or you know what? Leave the minus with the minus sign. That will give me cosine. Yeah. So that gives me square root of 2 cosine x over 2 times half from minus pi over 2 to or times 2. Oh, it's times 2, sorry. Yeah, I need the 2 to cancel the half later. Yeah. Or you can do it through the substitution. Yeah, I need to get rid of the half, so I need to multiply by 2. Okay. So that gives me what? 2 square root of 2 cosine 0 is 1. That's it. Yeah, let me do the calculation here. It will be 2 square root of 2 times what? Cosine 0, which is 1, minus cosine minus pi over 4, which is cos square root of 2 over 2. Square root 2 over 2. And that gives me 2 square root of 2 minus 2. And that's the answer. So this is the trick. And the rest is just calculation. Let me do this one. Cosecant to the power 4 of x. Yeah, the only things comes to my mind in 1 plus cotan square equal cosecant square. So this one I can rewrite as what? Cosecant square x cosecant square x dx. That give me one of these cosecant square. I wrote it this way. So now the integral pi over 4 to pi over 2 of cosecant square. This is one integral, and the second integral is cotan square cosecant square x dx. Okay. This one, easy to do. Integral of cosecant square is what? Minus cotan x. Yeah. You know the formulas. Just to remind you. Where is it? Where is it? Yes. Integral of cosecant square is minus cotan. Okay. And this one, I can let u cotan. This is will be du. What's the derivative of cotan? It's minus cosecant. I need the minus sign. So this is, yeah. So I'll put the minus sign somewhere. So I let this one is minus cotan from pi over 4 to pi over 2. And this is easy to do. Let me do the other one. Here I let u equal cotan x du is minus cosecant square dx. So I need the minus sign and the minus sign outside. So that gives me minus integral from where to where. Cotan pi over 4 is 1. And cotan pi over 2, which is cosine pi over 2, 0 over 1, that will be 0. Okay, this is du, u square. U square du. Where u is here. So I have what? Yeah, I need to do the calculation. Let me go here. Minus cotan minus cotan pi over 2. We say cotan pi over 2 is 0. Cotan pi over 4 is 1. This is the first one. Minus, this is u cubed over 3. U cubed over 3. U cubed over 3 from 1 to 0. That gave me minus 1. That gave me 1 minus. This is 0 minus 1 over 3. That gives me 1 plus 1 over 3, which is 4 over 3. And that is my answer. Yeah, let me stop the recording. I think we have a good number of questions. Let me stop the recording. I don't want to be big in long videos. Thank you.